In previous lessons, we've looked at the units of measurement and we've looked at the number of measurement. We started talking about when you make a measurement, you can only know certain digits with certainty. You add one extra one beyond that, and those are called significant figures or significant digits. Now we're going to need to be able to take those calculations that we're seeing on paper that we make and put them into a calculation. We want our answer to be reflective of the measurements that went into that calculation, and there's certain rules we have to follow in order to make these calculations correct or answers correct at the end of the calculation. Okay, so there are rules for addition and subtraction, which we're going to look at first, and then there's rules that are completely different if it's multiplication and division. We'll look at that second. There's rules for logarithmic scales, but we're not going to look at that right now. We'll wait until we're ready to use that kind of calculation later on in the semester or next. So let's look at the rules for addition and subtraction. Okay, so here's the rule. When you decide on your answer, it cannot have more digits to the right of the decimal point than any of the original numbers. Okay, so we're focusing in on digits to the right of the decimal point. We call these decimal places. Okay, so let's consider a measurement where we have to add numbers. So let's consider that maybe we made a measurement of length in centimeters. And this measurement of length we used with a device that had really finely integrated markings with lots of markings on them. And then we measured another length with a completely different apparatus that we can only know to the nearest tenth of a centimeter. So these were measured with completely different devices. One where I knew with a lot of accuracy and the other one not so much. And I want to take those two lengths and add them together. This will be in centimeters, but this answer can't be correct. So what do? We have to make sure that our answer doesn't have any more places to the right than the one with the smallest number to the right. So when we compare those two values here, this one has only one decimal point, one place to the right of the decimal point. And so this one would have to be rounded to an answer of 90.4. Now this is where students really dislike this method. They think, surely this is a good answer and this is less accurate. I've actually had engineering students sit down and say, I can't do this, we're just throwing away good information. It's not good information. We cannot know this measurement any better than this if one of our instruments we're using can only know the length to one place past the decimal point. So this is how you do it for addition and subtraction. Subtraction is the same way, okay? I have two different instruments I'm measuring. Maybe it's mass. Maybe this is so many grams and I want to subtract out the weight of the container and I weighed it with a different balance that knows it to a lot more places, and when I subtract these two I cannot know all of these places. So when I do this work, we're going to find out that with two places to the right of the decimal point on this number, I can only know my answer to two places to the right, and we have to round. So a little bit about rounding. If we're keeping two places, okay, and I'm going to keep these two right here. In keeping those two places, I look at this digit right here and I say, hey, that one is bigger than 5, so I have to round up to 0.79. Most of you will be familiar with that process of rounding up. A 5 or greater will make you go up to the next digit. So we are losing significant figures in our answer. So if our answer is this many grams, you might say, yeah, but my calculator said it was this many grams. I've thrown away good information. I haven't thrown away good information. I'm only keeping what I'm allowed to know based upon the measurements that I am making. So we have lost significant figures because this had total sig figs 3. This had total sig figs 5. And now I only have 2 total significant figures in my answer. We can lose significant figures. It can get smaller in the number of significant digits that we are allowed to keep, but it is an accurate thing to do. Okay, now this set of rules is so easy to forget. Students go off and start doing multiplication and division, a lot of multiplication and a lot of division, and they zoom in on that definition and or that rule and they forget about this one. So make sure you don't forget this one, even though you don't use it very often. So now let's look at the rule for multiplication and division, certainly the rule that you will use more frequently than any other. And here's the rule. The number of significant digits is in the result, in your answer, is set by the original numbers that has the smallest number of significant figures. So now we're actually tagging into sig figs, not looking at decimal places. So here are two measurements, okay? Let's say that one is a length, let's say it's meters. The other is a length, it's in meters. And so now we're going to have an area, and it would be in meters squared. Okay, so that's how you do a measurement of area, length times width. Now, we measured one length with a device that can only do it to the nearest hundredth of a meter. The other device, we can do it to the nearest 10,000th of a meter. Okay, so these two things measured with completely different devices. We have to make sure that our answer reflects the fact that we can't know this near as well as we knew this, significant figure-wise. Okay? So we know that this has 3 significant figures, so our answer can only have 3 significant figures. If we're going to round it, we would round it to 16.5 because we're keeping these 3. We're getting rid of this one, and that one is less than 5, so we won't need to round up, and our answer would be in meters squared. Same thing applies if you're dividing. Okay, so we do 6.8 divided by 112.04, and when we plug it into our calculator, which knows nothing about measurements, knows nothing about significant figures, spits this value out. Let's imagine that this was a density calculation, and this was in grams, and this was in milliliters, and so this would be in grams per milliliter. Okay, so now we've got our calculation out there, and with this, we know that we can't keep all those digits. We see that the 6.8 with its only 2 significant figures and the other one with its 5, we can only keep 2. So we have to be really careful which 2 we're going to keep. So we come through here and we see, all right, we've got this guy has not significant, but we have this one that's significant, this one's significant, and that's the 2 we want to keep. Underline it 3 times, those are the 2 we want to keep. We look at this one right here and we see that that's 5 or larger, so we need to round up, and that will give us our answer of, and let me erase that and get it out of our sight, of 0.061, and what would the units be? Well, we did a division of grams and milliliters, so it would be grams per milliliter. So that is the rules for multiplication and division. Now sometimes we're going to have a calculation in which we've got to do both. We have to do multiplication and division. We have to do addition and subtraction. What do we do in those cases? Well, if it's a multi-step calculation, you're not going to want to round along the way. You want to keep all your significant figures, carry them, let your calculator carry them. Don't put them in, just carry them on as you do your calculation. And then at the very end, you're going to round by following the rules and thinking about the rules as you go. So you're going to keep track of those sig figs and do a check of things as you go. So here's an example of what I'm talking about. When I subtract these 2 numbers, I get 4.59, and that's carrying all the significant figures that would come from my calculator. And then I want to divide that, let's get it back here. I want to divide that by the 3.99. So I plug that into my calculator, okay? And when I plug it into my calculator, look at all these digits I will get, okay? I'm getting all of those right there. Now what have I underlined in red here? Over on the left-hand side, underlining in red. Well, this is how many places that I should be able to keep from this subtraction that we see here. Because this has 1 place to the right, this has 2 places to the right, I can really only know that to 1 place to the right. Now, do I round at this point? No. I keep that as I do my calculation, but I underline it knowing that I really only have, keeping 1 place to the right, this only has 2 significant figures. And then this has 3 significant figures, so when I do the division then, my answer can only have 2 significant figures, and I better round up. This is a 5 or greater. So I'm not going to keep it as 1.1, it's going to become 1.2 in my answer. Okay, so that's multi-step. I do want to mention here that there is a discussion in your book, it's on page 25 and 26, about accuracy and precision. I want you to be able to look at those definitions and be able to look at a set of numbers and decide these set of numbers are accurate and precise, or maybe these set of numbers are accurate but not precise, or these set of numbers are precise but not accurate. I don't know if I just said all three of those, but you get the point. You should be able to look at data, know the definitions, and be able to look at data values and decide how they fit into those two categories.